Hello students. So in this class, we will discuss our chapter 7, okay, which is the last topic of the first semester exam of your ICSE board exam, right? Which will be conducted in the month of November. पता है सब लोगों को, right? सो ये हमारा साउंड चैप्टर है जो कि लास्ट चैप्टर है फर्स्ट सेमेस्टर का। ओके, फर्स्ट सेमेस्टर आईएससी बोर्ड स्टूडेंट के लिए ये लास्ट चैप्टर है। ओके, कौन सा एग्जाम के लिए? फर्स्ट सेमेस्टर के लिए। सो स्टार्ट करते हैं। एंड फर्स्ट सेमेस्टर में आई टोल्ड दैट ओनली दीज थिंग्स, ओके, only the first part is required, okay, up to sonar. The second part, these things are there in the second semester. So without wasting time we can start. सही है बच्चों? ठीक है। सो ये हमारा बेसिक टॉपिक है जो तुम लोगों ने क्लास 9 में ही पढ़ रखा है, ठीक है। और एक बार डिस्कस कर देते हैं, यहाँ से छोटा छोटा क्वेश्चन मिल सकता है, ठीक है। शॉर्ट क्वेश्चन, डायरेक्ट वन लाइन क्वेश्चन, ओके, यू कैन गेट। ओके, सो चलते हैं, मार्क कर देंगे मैं, ओके, हाईलाइट कर देंगे और तुम लोग बुक लेकर बैठ रहो, बुक एंड पेन, ओके, और हाइलाइटर व्हाटएवर, एंड यू आल्सो हाईलाइट द इंपॉर्टेंट पॉइंट्स, ओके। So in case of sound wave, this thing you had already read in class 9 that the propagation of sound wave, a medium is required, okay. Sound requires a medium for its propagation, okay. And from where the sound is generated? A vibrating body causes vibration in the particle of the surrounding medium, okay. When I am talking, okay, or you are talking, then the vibrating body is your mouth, okay. Sound is coming from there, and the particle present in front of your mouth, the air particle, all these particles vibrate, okay. And in the particle of the vibration in the particle of the surrounding medium, okay, and which travels in the form of wave with certain speed, and this speed depends on the nature of medium, okay. Speed will be different in liquid, different kind of liquid. Speed will be different in solid, speed will be different in liquid, okay, in gas also, okay. So depending upon the medium means depending upon the density and elasticity of the medium. Elasticity is a property of medium which you will read in class 11 in details, okay. So now come to the sound range which we can hear, okay. Frequencies from 20 hertz to 20 kilohertz, okay, 20 hertz to 20,000 hertz. This frequency range is also audible to human body, so this is called audible range of frequency, but it depends on person to person. When the person gets older, then the hearing ability decreases, okay. In that case, the range of audible frequency will also decrease. It will not be 20,000 hertz, okay, but this is written in general. 20 hertz to 20,000 hertz is for the audible range, okay. Keep in mind for short question, okay. Come to the next thing. The next thing is the sound of frequency above 20,000 hertz. This one we cannot listen. This is called ultrasonic sound wave, okay. This is called ultrasonic. And while the sound of frequency below 20 hertz, this one also we cannot listen, so this is called infrasonic. So there are three ranges. One is below 20,000, that is called infrasonic, right? That is called infrasonic. One is above 20,000, that is called ultrasonic, okay. Both these range are not audible to human being, and the range between 20 hertz to 20,000 kilohertz is audible to human being, okay. That is called audible range, okay. So it is written here, both ultrasonic and infrasonic are inaudible to human being, okay. Both ultrasonic and infrasonic are inaudible to human being, but they both travel with the same speed in any medium, okay. They both travel with same speed in a medium, and the speed will be with the speed same as that of the audible sound. That means audible sound, ultrasonic, infrasonic, all the three kinds of sound wave propagates through a particular medium with the same speed. If we take liquid, okay, any kind of liquid, all the three range of sound will propagate with the same speed. If we take any solid, suppose iron, then it will propagate with same speed. Okay. Okay. Now come to different quantities related to sound wave. Okay, and these quantities will be applicable for any kind of wave. Like one thing is amplitude. Amplitude means the maximum displacement of the particle medium. Okay, the maximum displacement of the particle of medium. Okay, on either side of its mean position. On either side of its mean position, that is called amplitude. Okay. Time period, it is the time taken by the particle of the medium to complete one vibration. Now one vibration means what? One vibration means what? Suppose this is the this is one line, okay, and this is the mean position. Here many particles are there. This is one particle, I'm taking different color. This is another particle, this is another particle, different particles are there. Okay, and these particles are vibrating in this way, up down, up down. These particles are vibrating up down, up down. Okay, particles are vibrating in this way. Okay, particles are vibrating in this way. Then the particle, initially the particle was lying on this line. Okay, this position is called mean position. This position is called mean position. Okay, mean position, where the particle was initially at rest. Okay, total force was 0. Now the particle is going to this position at this end and this position at this end. So this is the maximum displacement from mean position. This is the maximum displacement from mean position. This displacement, this maximum displacement on either side, it is called amplitude. And the time required, okay, suppose the particle is starting from here. So it is going to up, okay, again coming back to mean, going to the other side, then again coming back to mean. Okay, that is called one complete oscillation. Okay, in one complete oscillation, what happens? Before starting the oscillation at t equal to 0, suppose particle is going up. Okay, and after completing one oscillation, particle will again go in the same direction, up. Okay, then we call that it is one oscillation. So the time required to complete that one oscillation, time required to complete then one oscillation is called time period. And frequency is the number of complete oscillation, number of vibrations made by the particle of the medium in 1 second. Okay, that is called frequency. So these are different terms that you have already read in class 9. Okay, come to next thing. Next thing is wavelength. Wavelength is the distance. Okay, wavelength is the distance traveled by a wave in one period. Okay, one period of vibration of the particle of the medium is called wavelength. Okay, suppose if I take the same diagram, okay, if I take the same diagram, suppose here I am drawing. So this is the mean position. Okay, one particle I am taking. This is one particle, suppose. Okay, this is the particle. And suppose the wave is propagating in this direction like this. Wave is propagating. Okay, now particle is vibrating up down. Particle will not propagate, particle will just vibrate up down. And in one complete oscillation of the particle, okay, the wave propagates some distance in the forward direction. That distance is called wavelength. Okay, that is written here. Now the relation between wavelength, frequency, and then speed of the wave, okay, or wave velocity, you can tell the relation. One relation is there. That relation is V equal to F lambda. Keep in mind this relation, V equal to F lambda. Okay. Okay. Come to next point. Now the one more relation is there between time period and frequency, and the relation is this one. This is the relation F equal to 1 by T. Okay, so keep in mind these two relations, V equal to F lambda, okay, and F equal to 1 by T. Okay, come to the next point. So our next point is the frequency of any wave depends on the source. Okay, keep in mind frequency of any wave depends on the source. Okay, source, vibrating source. Okay, and the velocity of wave and wavelength, velocity and wavelength. Okay, so three things we got. What was the relation? The relation was V equal to F lambda. Among these three quantities, this F depends on the vibrating source. Okay, if we keep the source same, frequency will not change. Now this V and lambda, these two quantity depends on the medium. Okay, these two quantities depends on the medium. So wavelength depends on the properties of the medium. Okay, velocity of wave and wavelength depends on the properties of medium in which the wave travels. Frequency depends on source. Okay, and velocity of wave and wavelength depends on the properties of medium. Now, the sound wave necessarily requires a medium for their propagation. That point I had already told, that sound cannot travel through vacuum. Okay, sound needs a medium. For that reason, the sound wave is called elastic or mechanical wave. Sound wave is called elastic or mechanical wave. In mechanical wave, what happens? When one wave is generated, then due to the change in potential energy and kinetic energy of the medium particles, the wave propagates. Okay, when the medium particles vibrate, there is a change of kinetic energy and potential energy. Okay, and due to this change, the mechanical wave propagates through a medium. For that reason, this kind of wave are called mechanical wave. Okay, now there are two kinds of mechanical wave. One is longitudinal wave, longitudinal mechanical wave. Another is transverse mechanical wave. Okay, the mechanical waves are of two kinds, longitudinal and transverse. Okay, okay. Now this longitudinal wave propagates through a medium by the formation of two things, compression and rarefaction. Okay, compression and rarefaction. Okay, there's the forming the compressions and rarefactions in the medium. This longitudinal wave propagates. Okay, so this sound wave can propagate in air, solid, and inside liquid. Okay, sound wave can propagate in air, in solid, and inside liquid in the formation of longitudinal wave. Okay, in the formation of longitudinal wave. Clear? This the longitudinal wave can travel in solid, liquid, as well as gas. For that reason, we got the 3 points here: sound wave in air, in solid, and inside liquid. So longitudinal wave can propagate through three kinds of medium, that is solid, liquid, and gas. Okay. But the transverse wave means what? Transverse wave means when the particles, medium particles, vibrate perpendicular to the direction of propagation of wave. Okay, suppose the wave is propagating like this in this direction. Okay, and the medium particles are vibrating up and down. Medium particles are vibrating up and down. That means sound is propagating in this direction, medium particles are vibrating up and down. ओके इसके लिए क्या होता है, क्या हो रहा है, द मीडियम पार्टिकल्स वाइब्रेट कर रहे हैं परपेंडिकुलर टू द डायरेक्शन ऑफ प्रोपागेशन ऑफ वेव. ओके, सो इस तरह का वेव को क्या बोलते हैं? ट्रांसवर्स वेव. ओके, ट्रांसवर्स वेव. फाइन फाइन. Now this transverse wave, when sound wave in solid and on the surface of liquid. Okay, the example is sound wave in solid and on the surface of liquid. Okay, if you put one stone on the surface of liquid, then what you will see? You will see this kind of wave, right? That is transverse wave. And sound wave also propagates on the surface of liquid, forming transverse wave. Okay, and in few kinds of solid it propagates forming transverse wave. Okay, now transverse wave are formed only in those media where rigidity, okay, rigidity is there, where rigidity is there. And in gas there is no rigidity. In liquid rigidity is small. In gas there is no rigidity. Okay, rigidity means what? If you displace the gas particle, it will, and if you displace the gas particle by applying force, okay, now you remove the force, the gas particle will come back to its position again. Okay, that is rigidity. But in case of gas it does not happen. Okay, if air is there, if you give a force using your mouth, when you are stopping the force, will the particles come back to its mean position? It will not come back. Okay, so for that reason rigidity in gas is not there, rigidity in air, okay, is not there. You can tell that rigidity is negligible. Okay, in liquid rigidity is small. Okay, that's why they can travel only in solid, okay, and on the surface of liquid. Rigidity is there only on the surface of liquid. Okay, very small amount. Now this longitudinal wave travels in gas without any change in heat content of the medium. Okay, longitudinal wave travels through gas or travels through air without changing the heat of the medium. Okay, without changing the, you can tell, without changing the temperature of the medium. Okay, and the formula of longitudinal wave propagating through a gas medium is this one. This is the formula. V equal to root over gamma P by rho. What is gamma? Gamma is the ratio of two specific heats, which you will see in class 11. Okay, if we take air, its value we can consider 1.4. P is what? P is pressure. Okay, P is pressure. This P is pressure. It is written here. P is pressure, pressure P, and D is the density of the medium, density D. Okay, so keep in mind this formula. You can get direct relation. Which one of the following is the correct expression for longitudinal wave or longitudinal sound wave? Okay, in air. Okay, so this is the correct formula. Okay, suppose in place of gamma it is written 1.4. Suppose you can get this option 1.4 P by D. Then this option is correct. Okay, because 1.4 is the value of gamma for air. Okay, and this speed of sound in air depends on temperature, humidity. Okay, it does not depend on pressure. It does not depend on pressure. It depends on temperature. It depends on humidity. Okay, so if we increase the temperature, of air, then what will happen? If we increase the temperature, the gas molecules भागेगा, दूर दूर भागेगा, है ना? दूर दूर भागेगा तो क्या होगा? Density decrease हो जाएगा. Density of gas will decrease. If density decrease होगा तो V का वैल्यू क्या होगा? V increase हो जाएगा. Okay, and V increase हो जाएगा. ठीक है, and humidity बढ़ेगा तो क्या होगा? With the increase in humidity, humidity means water particle is increasing. Water particle, what is the molecular weight of water particle? H2O, 18 gram. And if humidity is less, then which thing will you take? You will take nitrogen, you will take oxygen, and their molecular weight is 28, 32, more than the water particle. Okay, so if humidity increases, water particle is increasing, molecular weight decreasing, that means density decreases. So in both the cases, so the speed of sound wave increases with the increase in temperature and with the presence of humidity. Okay, humidity बढ़ेगा तो क्या होगा? Density decrease हो जाएगा, क्योंकि humidity बढ़ेगा तो water particle आ जाएगा. Water particle का molecular weight कितना है? 18 gram. And if water particle is not there, very negligible amount of water particle is there, then maximum particle is nitrogen. Nitrogen means 28 gram. Oxygen means 32 gram. Okay, which is more than water particle. So temperature बढ़ेगा तो speed of sound बढ़ेगा, and humidity बढ़ेगा तो भी speed of sound बढ़ेगा. And the point I told, that speed of sound is not affected by the change in pressure. Okay, because pressure increase करेगा तो density भी increase करेगा. Okay, इस तरह increase करेगा कि P by D, in the formula P by D, pressure by density will remain constant. Okay, so that was the formula for, so I'm writing the formula again. So the formula was V longitudinal wave का क्या था? Gamma P by D. This was the formula of longitudinal sound wave. Okay. Okay. Now for transverse speed V of the transverse wave, this transverse wave speed का formula है root over T by M. Okay, here T means tension and M means mass per unit length of the string. Okay, when sound is propagating through a solid, that means sound is propagating through solid medium or solid wire. Okay, then tension will be there and mass per unit length of the wire, and we can get transverse wave velocity V equal to root over T by M. Okay, now this sound wave traveling in one medium, okay, passes to another medium. When sound wave is entering into another medium, suppose through air it is entering into liquid, okay, or into water, okay, or from water to air. Okay, that means when it is entering from one medium to another medium, then refraction will occur. Okay, like light wave, refraction will occur. The refraction means the wavelength will change, intensity will change. Okay, but the frequency will not change because frequency depends on source, right? Frequency depends on source of the vibrating body. But wavelength, then velocity, intensity, these things depends on the medium, nature of the medium. Okay, okay. And the direction of travel of wave will also change except for normal incidence. So all these things, this refraction is happening like sound wave. Okay, refraction is happening like sound wave. Now this sound wave differs from electromagnetic wave. Just in the last chapter you had read electromagnetic waves. What are their arrangement? First gamma ray, then X-ray, then UV ray, then visible light, then infrared ray, then microwave, then radio wave. This is the proper arrangement in the direction of increasing wavelength. Okay. So all these are electromagnetic waves. There is a difference between sound wave and electromagnetic wave. Sound wave is mechanical wave and electromagnetic waves are electromagnetic waves. For sound wave, medium is required. For electromagnetic waves, we had seen that medium is not required. As sound wave is a mechanical wave, so medium is required. Okay. So I'm not going in details again because already we had seen about the electromagnetic waves, what are their properties. Electromagnetic waves propagate through air or vacuum with 3 into 10 to the power 8 meter per second, which is very high speed. But sound wave propagates with only 340 meter per second or 330 meter per second, okay, which is very small. Now directly I am going to the difference between light wave and sound wave. Okay, light wave, it is an electromagnetic wave, and sound wave, it is mechanical wave. First point. Okay, light wave electromagnetic होने के नाते क्या होगा? Travel in vacuum. Okay, medium is not required. If medium is there, fine. Medium is not there, also fine. Light wave will propagate. But sound wave require material medium to propagate. It cannot travel in vacuum. Okay, the speed of light in vacuum is 3 into 10 to the power meter per second, which is very high. Speed of sound in air is 330 meter per second, which is low. Wavelength of light is very small. Okay, of the order of 10 to the power minus 6 meter. Wavelength of sound is large, almost 10 meter. Okay, and yes, 10 meter. And light wave is transverse in nature. Okay, but sound wave in air is longitudinal in nature. In air, mention this point, in air. Okay, don't write only the it is longitudinal in nature. It is longitudinal in air. Okay, in air, then in solid, inside liquid. Okay, but on the surface of liquid and in solid also, it is transverse in nature. Okay, if we take wire, then sound wave will be transverse in nature. Okay, so these are distinction. Now come to the idea, just the idea of reflection of sound. So reflection of sound, this is the main topic. Okay, in your ICSE syllabus. After that, echo is there, condition of echo is there, different application and simple numerical, all are there. Okay, that thing I'll discuss on the board because numerical is there. Okay, some concept is there. Okay, so reflection of sound wave also reflect like light wave, but here few differences are there. So sound wave can reflect, okay, by striking from a hard surface. Okay, striking from a hard surface. Return back in the same medium like light wave. Okay, obeying the law of reflection. One is angle of reflection is equal to the angle of incidence, and the incident ray, reflected ray, and normal at the point of incidence all lie in the same plane. Okay, so these are similar thing like light wave. Okay, but here for the reflection of sound wave we need hard surface. Okay, few more differences are there. Okay, the return of sound wave on striking a surface such as metal sheet, plywood, etc. back in the same medium is called reflection of sound wave. So this is the simple definition. Okay, the reflection of sound wave does not require smooth medium. Okay, that is the main difference. The reflection of sound wave does not require a smooth shiny medium, whereas for the reflection of light wave, smooth and shiny medium is there. That is, in most of the cases we use mirror. Okay, mirror we use in the case of light, reflection of light. But for the reflection of sound wave, we do not need this kind of medium. Okay, do not need means if there is smooth shiny, fine. Okay, if there is not smooth shiny, then also fine, sound wave will reflect. Now the reflection of sound wave does not require smooth and shining surface. Okay, if smooth and shining surface is there, fine, it will reflect. If it is not there, rough surface is there, then also it will reflect. Okay, but here sound wave get reflected from any surface, whether smooth or hard, but okay, smooth, hard or polished, rough, whatever. But the main requirement for the reflection of sound wave is the size of the reflecting surface. Size of the reflecting surface must be bigger than the wavelength of sound wave. We had seen just in the differences that the wavelength of sound wave is almost 10 meter. Okay, so for the reflection of sound wave, we need a surface. Maybe the surface is rough, smooth, polished, hard. Okay, whatever, but we need the size of reflector bigger than the wavelength of sound wave. Okay, must be bigger than the wavelength of sound wave. Okay, 10 meter is the wavelength of sound wave, must be bigger. And this phenomena of reflection of sound wave is used in megaphone, speaking tube. You all have used, I think you all have seen. One very good thing is speaking tube is if you take any this kind of shape, okay, and put one string and other side this kind of thing. Suppose one person is here, another person is here, and your ear is here, and this person is talking, then sound wave will propagate through this medium and you can hear it. Okay, so this is speaking tube, soundboard, ear trumpet. Okay, many examples are there, you all can see. Okay, so this is the first part that I wanted to tell. Okay, so just we have seen the reflection of sound, the basic idea, what kind of medium is required for sound reflection. Okay, so for the sound reflection, we do not need smooth shiny surface. Okay, if it is there, fine. If it is not there, if surface is rough, okay, if surface is not polished, okay, if surface is hard, okay, also it will reflect. Okay, sound wave will reflect. The main point is the size of the reflecting surface must be bigger than the wavelength of sound wave. Okay, the size of the reflecting surface should be or must be bigger than the wavelength of sound wave. ठीक है, सो यही दो चार पॉइंट तुमको याद रखना है। और जितने सारे पॉइंट बोले कि साउंड वेव एक मैकेनिकल वेव है, साउंड वेव ट्रांसवर्स भी हो सकते हैं, साउंड वेव लॉन्गिट्यूडिनल भी हो सकते हैं, another is electromagnetic wave which are always transverse in nature. क्या क्या डिफरेंस है साउंड वेव और लाइट वेव में? ओके, or when the sound wave is longitudinal, then through which kind of medium it can propagate. When sound wave is transverse, then through which kind of medium it can propagate. Okay, so these are different points, formulas of transverse wave, formulas of longitudinal wave we will keep in mind. Okay, so these are different points you will keep in mind. Okay, for direct short question, okay, so this is for today's class. I hope you have enjoyed, you have noted down, you have highlighted in your book. So keep watching and keep reading. Thank you everyone.